So this panel consists of Dr. Jagjit Bhattacharya ji, President, Center for Digital Economy and Policy. Ajay C. Jose, Founder and Managing Director of Elvecto Technology Private Limited. Parth Gandhia, Technical Director. Then Mr. Petho Rajan Bakshi, Operations Director. And S.P. Gupta, Superintendent Engineer, CPWD. And Ms. Vatsalya, Superintendent Engineer, Planning Road Asset Management Center, Karnataka. So may I call Dr. Jagdeep Bhattacharya ji for presentation, please.
He has not come, I think. Yes.
Okay, so Ajay C. Jose, please start the presentation.
Can you get my This is the one, no?
Yeah, yes. Thank you. Yeah, good afternoon, everybody. It is nice to be here, and I am really excited to present myself as the founder of Elvecto Technologies. And I am really privileged to be the part of this eminent panel, and I congratulate all the co-panelists. We are a smart intelligent parking solution provider from Kerala. We based out of Kerala, and we are providing airport grade parking solutions for smart cities, railways, and enterprises. And I think we all know about the challenges in parking. I cannot explain because you all already know about the challenges in parking. Over the past 8 years, we are being in this industry, and with our experience, what we realized is the challenges in parking is because the large number of vehicles are being rolled out in Indian roads. According to Ministry of Road Transport, there are about 390 million vehicles are in Indian roads as on today. So out of that, 70% are two-wheelers, and these 30%, remaining 30% are four-wheelers, and these 30% is creating a lot of traffic in Indian metropolitan cities. And we are thinking about a developed country by 2047. In such an aspect, we expect that the vehicle population might be increasing or doubled by that year. So increasing the vehicle population also needs the supporting infrastructure also need to be created. But unfortunately, we are not seeing the infrastructure creation is going very slow manner. So how do we address that? In our experience, we realized that there are three key stakeholders are making the value addition for creating a well-defined parking ecosystem. So first is the parking owners or the parking premises who provides the parking ecosystem for the public. And second is the public who are really looking for a parking facility. And third is about the governance and policies which the government is being created. So there is a clear disconnect between these three key entities. That is the main challenge which we face. So how do we address that? So if we can address these key stakeholders and connect each of them into a single service delivery platform, that is a solution. So we are bringing solution in a digitalized and intelligent way by creating digital assets for the parking garages. So existing parking ecosystem actually run with lot of high expensive ecosystems. So we wanted to reduce the cost of the existing garages. So that transition need to be brought. So we are bringing some value add in that aspects to create low expensive ecosystem for parking garages. Second is, as I mentioned, the second key stakeholder is the public who are really looking for the parking. So public does not have an insight where exactly the parking, free parking is all about. So if we can bring insight for the customer or public who is looking for a parking, so some frictionless way of giving an advanced way of understanding the parking, that is one way of addressing that challenge. And second is reducing the entry and exit times. So we know that if there is a huge traffic in any of the ecosystems, the queue is being piled up in the entry and exit ways. So we need to reduce that that transit at the entry and exit gates. So that will give harmony and frictionless environment for the public. And also need to give an insight, or before traveling to a particular place, the public need to know about the availability of the parking. That brings transparency. So we need to give that transparency. Either we can give some way of interacting through some public mobile application in this ecosystem, or there are so many applications available within the smart city ecosystem. So we can enable the parking insight for the public. Third is for the governance. So we all know that there are so many traffic jams are happening in the metros and urban ecosystems. Because of this traffic, the government is also finding, or the municipal corporation or the urban ecosystems also face so many challenges how to address this. They are not able to provide proper traffic ecosystem, or they are not able to give them proper traffic guidance systems for the public. So if you have a pattern of data which gives insight for the governance to create rules and regulations for these ecosystems, that will help to bring an full-fledged intelligent support system for these smart cities. So government can generate different aspects, or define some kind of rules and regulations by getting the data from these insights. They can create weekend tariffs, or even they can have better mobility planning based on the data. So all these leads to a same place where we need a converged platform, a service delivery platform that brings all these services into a single entity. So for that, we need to integrate the existing command control center or existing mobility ecosystems and the payment platforms into this platform. And the most important aspect of the digital penetration is we are talking about the ESG 230 goal. So by 2030, all the government and public sector is moving towards environment, sustainability and governance. So we need to create sustainability development goals for this 2030 goal. For that, we are providing some values, like there are scenarios where carbon emission is happening. So there are two typical scenarios where carbon emission is happening through people are searching for vehicle. So searching for the parking location. So that means your vehicle is turning around the city without finding a proper space. That itself creates a lot of carbon emission in the cities. Another scenario is people waiting at the exit gates and entry gates for the transit. So that creates a lot of carbon emissions. So we need to reduce that carbon emissions for gaining the carbon credits for the organizations or the enterprises. And smart city implementations. In the previous session, we heard that there are about 50 or 70% of success is in the implementation of smart cities. The failures are because we are not completely digitalized. We have created the infrastructure ecosystems, but we don't have a proper data integration is happen. So we need to create data integration through intelligent systems. That is the another aspect which we are supporting. So what is our commitment towards these smart cities or other enterprises is about less than 3 seconds entry and exit vehicle transit that we are offering, and we have high availability up to 99% and revenue pilferage zero revenue pilferage, and physical ticketing also being reduced. So together we are building a digital ecosystem through a sustainable platform for the smart cities. Thank you.
Namaskar. So my presentation will be mainly on the BIM and some aspect of sustainability into it. I represent Central Public Works Department, which carries a legacy of 171 years. It is one of the oldest department of Government of India. So we have gone for a digital transformation through BIM. And for BIM, it is said to be on 3 pillars of processes, people and technology. So basically processes means workflows. So unless we automate all the workflows in which we operate, like we all have a manual or code. So from our J level, A level, E level, then SE, chief, everything. So all the workflows of approval, initiation should be automated. Only then I think the next stage comes of people's training and capacity building. Then the third pillar comes in terms of technology and tools which we provide them for utilization. In a construction sector, as you know that we primarily operate in the built environment. So major challenges are in terms of delays. Most of the projects are delayed because of many reasons: approvals, local body approvals, change in scope, additional works, like that. Even maybe some missing items in the initial estimates. Then cost overruns is a second most concerned cause of delays, then taking the cost escalations into that projects. Quality issues may be both in terms of the cost of quality of construction as well as the quality of overall built environment in terms of its utility and comfort. The recent trend is increase in arbitration and litigation, maybe because of various reasons, maybe additional works, delays due to delay in decision making. So this leads to escalation in cost. Then the foremost challenge nowadays is scale and complexity. As you know that for a typical project of costing 1,000 crore rupees, around 2,000 to 3,000 people work in a work site. So managing those kind of workmen, their trades, and the sequencing of tasks becomes really very challenging. So going for a digital transformation is not an option, but it's survival, an opportunity to complete the projects on time, within the cost, and of given quality. And of course, the foremost thing of importance today is sustainability and life cycle based decision making. I think all of you are aware of the 2024 in May, June, Delhi region has a very hot summer. Almost 40 days, it was 40 plus temperature. And I in my headquarters used to receive at least 100 calls daily that our AC systems are not working. Why? Because as you know that once the ambient temperature goes beyond 40-45 degrees centigrade, our AC system stops working. So what is the way out? it's very difficult to stand even outside during 45-degree peak summer. So what need to be done as a public departments, what decisions need to be taken so that we can mitigate this issue. Now coming to our processes part, so CPWD has gone for integrated ERP system in order to automate all our processes, in order to collaborative integration, real-time monitoring, transparency, accountability, and all these things. As all of you may be aware that in most of our projects, up to 90% it's good progress. But this 10% progress, it takes 30% time. Why? Maybe there's a over-reporting in the beginning, but as we come closer to closing of the project, we find the real difficulty in terms of coordination, in terms of finishing, in terms of collective working with all the streams in achieving the targets. Now this ERP system which we have gone for has inbuilt predictive intelligence. It can integrate SCADA, IoT, BIM, BMS, and all immersive technologies to it, including AI, machine learning, and data analytics. As you know that in the construction sector, we deal with a lot of data. It may be in terms of analysis of rate, scheduled rate, plinth area rate, cost, right? So all these things have been automated, and as of now, we have made 84 processes live, 57 are under development, 31 yet to start, and for 9, the user acceptance test is going on. It has taken almost 5 years to reach to this stage. It may take another couple of years to finish it. It's a long drawn process. Digital transformation is a long drawn process. It may even cause disruption in some stages. One very special feature of our ERP system is that we have gone for a collaboration and estimation tool in our own ERP. So only authoring of BIM related softwares need to be done outside the ambit of this. This tool has a feature of integrated 5D, means estimation, 4D, that is sequencing and time, then all the project development related reporting, documentation, access, and facility management can be done into this. So even the issue rectification, clash detection, and coordination control can be done into it. It's a wonderful tool. I think only few departments have done it so far. We have done it partly. The rest of the functionalities will be taken up maybe shortly. So this is the typical dashboard we have created for our CDE, that is Common Data Environment. So you can see that a lot of functionalities have been embedded to it. So why BIM for public works? We have seen that we need to address, there are so many issues before us in order to improve the quality of our living buildings, and in order to enter to area where we can call ourselves developed in terms of quality of infrastructure. So it needs integrated planning, design, construction, and even asset management. So BIM can enable us concept to completion, handover, and even asset management. So that is the beauty of BIM. It helps us in seamless collaboration between 30-40 consultants we have in a project, and fast decision making. BIM workflow is typical of this, like creating a BIM model, then going for a clash detection, then resolving clashes, clash-free model, then good for construction drawings, then BOQ, then sequencing, and maybe handover. So these are typical things. So with the BIM, we have a beauty to go from plan, design, build to facility management and operations. As you know that we have various LODs, right from concept to further design, then further fabrication, then up to completion stage. We can have a dimension of time, cost, sustainability, and facility management to it. Plethora of technologies available, tools available, but commonly Revit, Navisworks, Tekla are used. For a full-blown organization, this could be a typical structure of BIM. For even the existing building stock, we can go for 3D modeling through LiDAR. So if we integrate GIS and IoT in a BIM, we can get digital twins for monitoring and simulation purpose. I'm a member of India BIM Association, governing body member. So I would request all of you to join this organization. We have done a lot of work in NBC guidelines. These have been developed, and maybe the feedback has been invited by MIS. So these are the countries where BIM associations are active, and the India BIM Association has tied up with them. These are a few things. Now coming back to CPWD, we have introduced BIM policy in form of a booklet. It is introducing BIM in CPWD. It is available free of cost in our website. Anybody can go and download. So all the stages of BIM deployment have been discussed here. It's a policy statement, and it introduces to BIM environment. So this is our official document on BIM. We have gone for a phased implementation approach. We have gone for pilot projects, capacity building. We have developed some templates as well. And it is now mandatory for all works above 30 crore rupees. So it covers most of our projects in CPWD. So what we have gone, what benefits we have derived out of it is that we have done a clash detection. We have done quantity verification and validation. And we have improved the collaboration, which has led to improved coordination among the stakeholders. So these are the outcomes out of it, right? As you know, way forward that we have to go for gradual scalable adoption. These are few pictures we have done in all the projects, but only few pictures I have shown. Now, the very important part which I would like to share with you is that our Panchamrit commitment, which this country has made. So we have made 5 Panchamrit commitments. 2 are on the renewable energy, that is 50% demand by renewables and 500 gigawatt by 2030. 3, 4, 5 are very important and very much relevant to buildings and infra, built environment. Because built environment alone accounts almost 1/3 of the emissions, as pointed out by many speakers in the morning as well. So what we are doing, what as a planner, as an architect, as an engineer, we are doing for this? Are we ensuring that 1 billion ton CO2 emissions are being reduced by 2030? And how? How the economy's carbon intensity is reduced by 45%? Or how we are going to have a net zero by 2070? What we are doing to it? I have studied 65 projects in Central PWD, Pan-India. 3 major observations. Per square meter of plinth area, we are embedding 1 ton CO2 emissions. Per square meter of plinth area, right? 1000 kg of CO2 equivalent emissions. This is the first finding in our 65 projects. Second finding is that in 50 years time period, if building is a good one, moderate, 6 times, that is 6 ton of CO2 emission is accounted as a operational because of use of air conditioners and lighting and all those things. Right? So this is one building I studied just for sake of understanding. Glass facade is not suitable in our climate. Wherever there is a composite climate, lot of air conditioning required, please avoid glass facade. Number 1. Number 2, please optimize window wall ratio to 20%. These glass facade are energy guzzlers. Your emission will be doubling. So instead of reducing the emission by 1 billion ton of CO2 or reducing intensity by 45%, no, we are increasing it. So please keep these two things in mind. Just for your understanding, I have put this in for reference. These are the data we used. We use EPD of various manufacturers to calculate this. And very important conclusion, I would like to have your opinion on this. Most of our audience may be in various roles. Are you complying to ECBC? Maybe are you doing ECBC super in any of your buildings? If yes, please raise your hand. ECBC super you are doing? So are you achieving your U factor of wall, say 0.22 around? Please check it. Check your data sheet. Because if you say L4, insulation, unless you use EPS as a core insulation material, you will never get it. You just see out of 4.5 R value, 50% is accounted by EPS core only. Many consultants are not aware of it. I have studied over 50 projects. Only 2 or 3 cases I could find a satisfactory answer. Others, they say it's a GRIA 5, somebody will say it's IGBC. But if you see the envelope insulation, it is not fulfilling ECBC. Please go and check your buildings. Similarly, for roof, it should be like 0.2 for super ECBC. Here also, you can see that 80% insulation comes from EPS. Rest is okay. So these 2 things are very important. So with this I conclude. Thank you. Now I request my next speaker, Mr. Parth. Please. Parth Gandhi.
Okay. Yes. Good afternoon, all. So actually, I'm a technical guy, so I'll not able to, speak like a professional speaker, but I'll try to explain what exactly we are doing. So we are in very simple business. It's a light control and monitoring. So it's a street light controlling and monitoring. Actually, big cities have a big problem with light monitoring. It looks very simple, but if you go behind the bars, then you can see it's very complicated, and there is too much parameters to maintain and too much hurdles to maintain these. So it's very easy to say ये light repair नहीं हो रहा है, ये हो रहा है, वो हो रहा है. बट जब हम inside the kitchen जाते हैं तो बहुत सारी चीज़ें इसके पीछे है. So I like to show कि क्या प्रॉब्लम्स है और उसमें हमने किस तरीके का इंडियनाइजेशन किया है जिससे ये प्रॉब्लम्स को हम ऑप्टिमाइज कर पाए. सो अवर कंपनी नेम इज़ मी माइटी एंड दिस इज़ अवर प्रोडक्ट रेंज माइटी टाइमर. So our company is Surat, Gujarat based. We started in 2012 and we have 120 people passionate team जो डिज़ाइन डेवलपमेंट R&D पे इन्वॉल्व है और ये पर्टिकुलर प्रोडक्ट के अंदर हम लास्ट 10-12 सालों से काम कर रहे हैं. सो इट्स अ मिक्सचर ऑफ 3 थिंग्स. वन इज़ पैनल. सो एज वी ऑल नो कि 50-60 लाइट के बीच में एक नॉर्मली टाइमर होता है. वो टाइमर उसको टाइम टू टाइम चालू बंद करता है. एंड दैट इज़ दिस पैनल. जो पहली पैनल है वो दैट वी कॉल्ड ग्रुप स्ट्रीट लाइट कंट्रोल पैनल. दूसरा जो डिवाइस है ये थोड़ा नए जनरेशन का डिवाइस है जो हर एक लाइट के ऊपर लगता है और वो लाइट मॉनिटरिंग और लाइट कंट्रोल के लिए यूज़फुल होता है. आई विल एक्सप्लेन लेटर इन ब्रीफ. थर्ड इज़ दैट सॉफ्टवेयर जो हमने ये डिज़ाइन किया हुआ है एंड वी कॉल्ड इट माइटी टाइमर. सो देयर इज़ 2 टाइप ऑफ पैनल, सिंगल फेज एंड 3 फेज. 3 फेज इज़ फॉर मैनी लाइट्स लाइक 50-60 लाइट्स के लिए हम लोग 3 फेज यूज़ करते हैं. His light count is below than 20 around, then it is 1 phase. And it communicates to cloud with 4G, 5G and MBRT technology that depends on the requirements and site requirements. So this is how it is working. So ये feeder panel है वो जो इंटरनेट से कनेक्टेड है वो एग्जिस्टिंग फीडर के साथ कनेक्ट हो जाता है और ये लाइट के साथ कनेक्ट होके इंटरनेट पे ये एनालिटिकल डेटा भेजता है. सो दिस इज़ इंडिविजुअल कंट्रोलर. ये अलग अलग कम्युनिकेशन प्रोटोकॉल पे काम करता है. ZigBee है, LoRa है, MBRT है, Sigfox है. अब आपको लग रहा होगा कि इतने सारे प्रोटोकॉल क्यों है, बिकॉज इट कम्स इन टेंडर. जो बंदा महाराष्ट्र में जाता है वो वहाँ पे ZigBee बोल के आता है तो हमको ZigBee बनाना पड़ता है. सो इफ़ यू आस्क अस देन वी हैव सम फिक्स प्रोटोकॉल दैट वी सजेस्ट कि LoRaWAN इज़ मोर प्रीफरेबल इन दिस टेक्नोलॉजी. बट पूरे इंडिया में आपको ये सारे प्रोटोकॉल्स अलग अलग मैथोडोलॉजी में मिलेंगे टू कम्युनिकेट विथ क्लाउड विथ इंडिविजुअल लाइट्स. सो ये बेसिकली फंक्शन करते हर एक लाइट के ऊपर ये कंट्रोलर लग जाता है एंड इट कम्युनिकेट टू दिस फीडर पैनल, और फीडर पैनल फिर क्लाउड के साथ कनेक्ट होता है। तो इस तरीके से इसका कनेक्शन रहता है साइट पे। दिस इज़ अवर सॉफ्टवेयर प्लेटफॉर्म। एक वेब पोर्टल है जहाँ पे लाइट का सारा डेटा आता है। देयर इज़ वन मोबाइल एप्लीकेशन जो साइट पे कोई बंदा है वो एप्लीकेशन में देख सकता है। एंड नाउ वी ऑल आर पीपल आर डिपेंड्स ऑन व्हाट्सएप। तो हमने ये सारा डेटा व्हाट्सएप पे भी डाला है। तो आपको अगर बार बार वो पोर्टल नहीं देखना है या फिर यू आर नॉट कन्वीनियंट टू सी ऑन एप्लीकेशन, तो सुबह 8 बजे आपको एक मैसेज आ जाता है कि कितने लाइट यस्टरडे बंद थे, क्या रीज़न से बंद थे, एंड दैट व्हाट वाज द एक्टिविटी ऑफ लास्ट डे, सो दैट यू कैन सी इन व्हाट्सएप ऑल्सो। सो एंड अनदर थिंग वी डेवलप्ड, अभी तक हमने देखा है कि हर एक कॉरपोरेशन के पास अलग अलग सॉफ्टवेयर है फॉर अलग अलग मैन्युफैक्चरर्स। So we are proposing common software for all kind of different panels, which is very useful for any corporation. क्योंकि we standardize all the data, क्योंकि एक लाइट के लिए क्या डेटा चाहिए, तो we make the list of that light data कि हमको एनर्जी कंजप्शन का KWH का डेटा चाहिए, यस्टरडे कितने लाइट हमारे बंद थे वो हमें चाहिए, क्या कंजप्शन था और कितने लाइट लगे हुए थे, उसमें से क्या क्या फॉल्ट के टाइप थे। सो वी मेड लिस्ट ऑफ दिस पैरामीटर एंड वी आर पुशिंग टू दिस टाइमर OPS डिवाइस सॉफ्टवेयर। एज ऑल वी नो, इंडिया इज़ नॉट फॉर बिगिनर्स एंड आई मस्ट से नॉट फॉर फॉरेनर्स, क्योंकि यहाँ का काम काज करने का तौर तरीका समझ बहुत अलग है। एंड वी डेवलप दिस इंडियनाइजेशन फ्रॉम लॉन्ग एक्सपीरियंस। सो मैं उस पर नहीं जाऊंगा कि क्या क्या टेक्नोलॉजी और है। आई विल शो यू सम थिंग्स जो हमने एक्सपीरियंस की है और हमने कैसे इसको सॉल्व किया। सो एज यू कैन सी, बहुत सारी डिटेलिंग होती है दिस काइंड ऑफ IoT प्लेटफॉर्म। हमने इसको बहुत सिंप्लीफाइड किया है। एक सबसे बड़ा प्रॉब्लम होता है लाइट नहीं चलने का, दैट इज़ पावर कट। जो डिस्कॉम ने पावर नहीं दिया, दैट इसकी वजह से लाइट्स नहीं चलती है। सो एज यू कैन सी ऑन पोर्टल कि टोटल लाइट्स है 974, उसमें से ये कुछ लाइटें नहीं चल रही और किस रीज़न से नहीं चल रही है। सो फर्स्ट रीज़न इज़ पावर कट, उसके बाद कॉन्टेक्टर फॉल्ट हो सकता है, किसी ने MCB बाईपास कर दिया, किसी ने डोर खुला छोड़ दिया है। सो ऑल थिंग्स यू कैन सी इन सिंगल कार्ड। बाकी बहुत सारे डिटेल पैरामीटर्स इसके अंदर है। सो एक बहुत बड़ी चैलेंज थी इंडिया में हमारे पास कि लक्स सेंसर बेस्ड लाइट होनी चाहिए। हमारे सबके अंदर ये एक परसेप्शन रहता है कि रात को लाइट डिम हो जाए या आउटर लाइट्स कम हो जाए तो ऑटोमेटिकली लाइट चालू हो जानी चाहिए। लेकिन इंडिया में एक तो डस्ट इश्यूज बहुत ज़्यादा है और बर्ड ड्रॉपिंग बहुत ज़्यादा है। तो क्या होता है, वो लक्स सेंसर पे बर्ड ड्रॉपिंग हो जाती है, लाइट दिन में चालू हो जाती है। दैट इट बिगेस्ट चैलेंज। दूसरा, रात को कोई लारी लेके निकलता है और उसकी लाइट लक्स सेंसर पे लगती है, तो लक्स सेंसर को लगता है कि दिन हो गया है, तो वो लाइट बंद कर देता है। सो दिट्स काइंड ऑफ प्रॉब्लम्स वी सीन। सो हमने सोचा उसका क्या सॉल्यूशन निकाल सकते हैं। सो हमारी हर एक पैनल GPS इनेबल्ड है, तो हमको पता है कि एग्जैक्ट कहाँ पे पैनल लगा हुआ है। सो हमने एक वेदर सैटेलाइट कंपनी से कम्युनिकेट किया। वेदर सैटेलाइट कंपनीज गिव अस क्लाउड डेंसिटी। तो हम लोग 5 बजे स्टार्ट कर देते हैं वो API से डेटा लेना। अगर क्लाउड डेंसिटी इज मोर देन 70-80%, देन वी आर प्रिडिक्टिंग लक्स। तो जो लाइट सनसेट के हिसाब से 7:30 या 7:35 को चालू होने वाला था, तो हमको 6 बजे पता चल गया कि यहाँ पे क्लाउड डेंसिटी ज़्यादा है, तो हमको उसको प्री ट्रिगर कर देना है। सो बाई डूइंग दिस वी सॉल्व दिस प्रॉब्लम वेरी फाइन, वेरी इफेक्टिव वे। और यहाँ पे मुद्दा आ जाता है कि कॉस्ट, क्योंकि हम API का पैसा दे रहे हैं। तो वी ऑल नो कि अगर रेनी सीजन है तभी API यूज़ करने और 5 बजे के बाद ही यूज़ करने। So by doing this, we are optimizing pricing and solve this problem. दूसरा एक सबसे बड़ा प्रॉब्लम है, हर एक कॉरपोरेशन में एक ऑडिट रहता है कि प्री मॉनसून एक्टिविटी में बंदा उधर जाता है, चेकलिस्ट होती है उसके पास कि वो फ़ोटो खींचता है कि पैनल बराबर है, उसके अंदर वायरिंग सब सही से चल रहा है। वी ऑल नो वो सब ऑफिस में होता है, साइट पे एक्चुअल में चीज़ें नहीं होती। फोटोज़ भी एक ही फ़ोटो बार बार जब वो चढ़ा देता है, बिकॉज वी आर डिपेंडेंस टू मच ऑन टेक्नीशियन लेवल एंड दे हैव दिस हैबिट्स। सो वी मेड वन एप्लीकेशन। हमारे फीडर पैनल के अंदर एक ब्लूटूथ डिवाइस है, वो एप्लीकेशन तभी खुलेगा जब आप फीडर पैनल के पास जाओगे, एंड दैट इज़ डिजिटल डेटा कि वो फीडर पैनल का एक फ़ोटो लेगा। हमारे पास ऑलरेडी एक पुराना फ़ोटो है, सो वी इंट्रोड्यूस AI हियर कि पुराना फ़ोटो प्रेजेंट फ़ोटो से कितना मैच करता है। अगर वो डिफरेंसेस है, दैट डिफरेंट इज कैन सी ऑन पोर्टल, और उस तरीके से आप अगर एक सिटी में 5-6 हज़ार पैनल लगे हुए हैं दैट यू कैन सी इन डिजिटल फॉर्म, और वहाँ पे बहुत कम गुंजाइश रहती है कि कोई मैनिपुलेशन करेगा इसको. सो दिस फीचर वी इंट्रोड्यूस इन अवर सॉफ्टवेयर. सेकेंड इज़ वेरी इंपॉर्टेंट कि कई बार हमारे साथ ऐसा होता था कि हमने इंस्टॉलेशन कहीं पे कर दिया, आफ्टर 5 days 6 days कॉरपोरेशन सेज अस कि तुम्हारा पैनल किधर है, सो वी डोंट हैव एनी प्रूफ. सो हमने वहाँ पे भी एक डिजिटलाइजेशन किया कि ऐप के थ्रू अगर आप फोटो खींचते हो तो वो लेट लॉन्ग के साथ वो पूरा डेटा पोर्टल पे चला जाता है, एंड दैट सेम डेटा वी आर यूटिलाइजिंग फॉर ऑडिटिंग पर्पस, जो मैंने आपको आगे बताया. उसके अलावा सिटीज़न कंप्लेंट, इंडिया में एक सिटीज़न कंप्लेंट यूटिलाइज फॉर पॉलिटिकल रीजंस, राइट. लोग क्या करते हैं, इतनी सारी कंप्लेंट्स फेक डालते हैं तो कॉरपोरेशन वहाँ पे फंस जाता है. सो एज वी ऑल नो कि कॉरपोरेशन फिर क्या करता है, वो लिंक बंद कर देता है. सो स्ट्रीट लाइट के लिए हमने सोचा कि ऐसा हम क्या कर सकते हैं कि कॉरपोरेशन को इसमें इन्वॉल्व नहीं होना पड़े. सो व्हाट वी डन कि हमारे पास हर एक फीडर पैनल का डेटा है. अगर पावर कट है और कोई सिटीजन कंप्लेन करता है तो वो पोल के थ्रू हम ट्रैक कर लेते हैं कि कौन सा फीडर पैनल है, और वो फीडर पैनल जो है वो पावर कट की वजह से तो डायरेक्ट मैसेज चला जाता है सिटीजन को, यहाँ पे पावर कट है. रात को 2 बजे अगर उसको पता चलता है कि साइट पे वो पावर रिकवर होता है तो उसको व्हाट्सअप मैसेज चला जाता है, पावर हैज़ बीन रिकवर विदाउट एनी ह्यूमन इंटरवेंशन. सो दिस फीचर वी इंट्रोड्यूस बाय दिस. दूसरा एक डिस्कॉम एनर्जी रिकन्साइलेशन है. दिस इज ऑल्सो बिग प्रॉब्लम फॉर एवरी कॉर्पोरेशन. वो सिर्फ बिल भरते हैं, उनको आइडिया नहीं कि एक्चुअल कंजप्शन कितना है. सो वी नो कंजप्शन, तो हम वो ऑडिटिंग बिल ऑटोमेटिकली ये सिस्टम के अंदर करके देते हैं. एंड दिस इज वन मोर थिंग, दिस इज ड्रोन बेस्ड स्ट्रीट लाइट ऑडिटिंग. वी ऑल नो कि प्री मानसून में एक बंदा गाड़ी लेके निकलता है, वो लाइट्स को देखता है, कितना इफेक्टिवली देखता है, दैट नो वन नोज. सो हमने यहाँ पे ड्रोन का लेट लॉन्ग के हिसाब से एक फुटेज ट्रैक किया, एंड दैट ट्रैकिंग वी स्टोर्ड इन आवर सिस्टम. अगर वो बंदा दूसरे 6 महीने बाद या दूसरे राउंड में उसको मैच करेगा, वी आर मैचिंग दिस फुटेज एंड टेलिंग देम कि यहाँ पे लक्स का डिफरेंसेस जनरेट हुआ है. एल्स मोर फीचर्स, वी ऑलरेडी डन मोर देन 3 lakh स्लाइड्स ऑन पोर्टल, एंड नेक्स्ट वी आर इंट्रोड्यूसिंग इंडिया टू इन जर्मनी. हम वहाँ पे ये प्रोडक्ट प्रेजेंट कर रहे हैं इन लाइटिंग बिल्डिंग एक्सपो विच इज़ इन फ्रैंकफर्ट जर्मनी. Thanks a lot, and for more information you can connect and you can scan this QR. Thank you very much. Thank you.
Thank you. Now next speaker Patho Rajan Bakshi ji.
So good afternoon everyone, and thanks to the organizers for arranging this platform to discuss these emerging technologies. We all know that BIM, that is Building Information Modeling, is one of the emerging technologies in construction, which is changing the way this entire industry operates through all the phases, means from the design, the construction and the maintenance phases. The key benefits of this is that even before breaking the ground, even before the project starts, we can have the exact visualization of the project, the 3D visualization of the entire project that helps in planning and a lot of decision making processes. We can extract very accurate quantities and BOQs from the BIM model itself. And during the construction phases, when various changes happen on site, these changes are updated in those models, and in the end we generate the as-built model. It is called the LOD 500 model. This model is in turn handed over to the maintenance and facilities team. So these are the key benefits of BIM. And now as far as implementation and adoption of BIM in India goes, we are still at a very early stage. The awareness, some key government bodies like CPWD and NBCC, they have taken a big role in promoting this subject of BIM. CPWD in the year 2023, they have introduced BIM for most of their projects which are 100 CR plus. They brought down the figures to 30 crores in the year 2025, and they have again published a notification that starting from 2026, these figures will be brought down to 5 crores. Means they are expanding the entire scope of BIM. This is followed by NBCC, which is again another big Navratna PSU. They build buildings across pan-India basis who are promoting BIM. Apart from that, the central government, other organizations like Delhi Metro, Airports Authority, even MES is implementing BIM across all their projects. Coming to the state governments, some of those governments of Gujarat, Madhya Pradesh, Maharashtra and Haryana, they have also started introducing BIM in their public sector tenders. I am representing Agents, which is a BIM service provider based in Kolkata. I am heading their operations. We are regularly delivering BIM projects to consultants who are associated with consultants and developers, and we create these BIM models for their projects. One of the constraints that we face is that we can find this entire BIM scope is placed as a part of the EPC tender. In other words, the vendor who wins the contract, it is in his scope, but since the awareness and expertise is lacking, they are in many instances they face difficulties in creating this BIM model. So if this domain is floated as an independent discipline in the tenders itself, that will be a great help for all players in this discipline. To this effect, we have seen that in CPWD in Feb, CPWD Calcutta region have floated an independent tender on BIM, where they have floated BIM as an independent discipline for one of their upcoming PNB staff training institutes in Calcutta region. So that is one good news. But still, this sector is still considered as an unorganized sector since standards, codes, and industry practices are still lacking in this. So, Indian BIM Association is working with Bureau of Indian Standards to roll out some of the codes and standards which to take this sector forward. One more area which needs focus is the inclusion of BIM in academics. Although there is a huge demand in the industry, it is nowhere taught in the academics in a structured manner. None of those semesters are having this subject. So this is one area which we feel that has a lot of space to explore, lot of space to contribute. That's all. Thank you, sir.
Thank you. Next is Miss Vatsala, Superintending Engineer, Planning, Roads, Assets Management Center, Karnataka.
Okay. Hello everyone. Today I'll be presenting on data-driven asset management for sustainable mobility. How Karnataka government is transforming its road asset management into a sustainable and a data-driven approach. So I have structured my contents into these 6 areas. So why sustainable mobility matters, and what is the institutional response, and what are the technologies and systems involved, and the decision making framework, and the outcomes and impact of this data driven approach, and finally about the future roadmap, that how this enables us in attaining a sustainable mobility. So why sustainable mobility matters for our road networks? Sustainable mobility refers to a transport system that is environmentally responsible, economically efficient, socially inclusive on a long run. So it has been a critical priority for the government of Karnataka. Due to the growing traffic demand, we can see there is an increasing pressure on the existing infrastructure. So due to this traffic demand, there is an increase in the maintenance costs and also in the expenditures. And also rapid urbanization and motorization is causing an impact on this increase in cost. Due to this, there is an increasing pressure on the road infrastructure, which means the roads are used beyond their designed life capacity. So there is an overall rising in the maintenance cost, and due to poor road conditions, we can see the increase in the number of accidents and also in the increase in the percentage of the emissions. So this is also a matter of road safety and environmental concern. So this sustainable mobility, it is not possible without the scientific asset management. So in this slide, we can see the core problem and the solutions. Here we are comparing the traditional approach with the data-driven approach. We can see that the road management practices, they have often been very reactive. It means to say that actions are taken only after a visible failure occurs in the road. And this is often driven by complaints, the emergencies, or any visible damages. And also the data pertaining to the road conditions, such as the traffic data or the road condition data, and also any maintenance histories. These are all available in separated, isolated systems, and some of them are also usually in non-digital forms. So as a result of this, proper analysis is not possible. So there is no life cycle optimization, and also it is seen that the planning is only budget driven rather than need driven. These are the results: the poor ride quality and the unsustainable spending. So next is the data driven approach. Here we can see that the road maintenance works are predictive in nature. We can use scientific planning framework with standardized data collection, and it is also integrated with the GIS systems. So we can, due to this analysis, we can achieve a life cycle optimization and also an economic optimization. And the results are improved ride quality and an optimized cost. In this slide, we can see the road network of Karnataka. So the Karnataka Public Works Department, it has a responsibility for the development and maintenance of national highways, state highways, and the major district roads. We can see the category of road. Here national highways account for about 8% of the total network, and state highways about 31%, and MDR, which is the major, it accounts for about 61%. So we can find the scale and complexity of road network management here. The state highways and the major district roads are maintained by 4 zones of PWD: North, South, Central, and Northeast, and whereas the national highways are maintained by the National Highway Zone. Next is about the organization. PRAMC is Planning and Road Asset Management Center. It is a central unit under the Public Works Department, Government of Karnataka. It was established in 2016 to strengthen the institutional capacity for road planning, asset management, and road safety across the state. So PRAMC has a vision to manage and plan road networks efficiently with safety, sustainability, and data-driven decision making. So to achieve this vision, it focuses on 3 key areas. So integrate road safety in planning and implementation, use of scientific tools for the asset management, and enable capacity building and technical support across the PWD units. Here we can see the road asset management framework. It is built on scientific data collection approach. So we can see a continuous closed loop process here. We begin with the inventory of the road conditions, then we assess the condition of the roads, then a performance evaluation is being carried out, then it is followed by prediction in the deterioration of the road surfaces, then a life cycle cost analysis is done. And the result of this life cycle analysis, it is then fed back into the prioritization, and we come up with the annual works program. The outcomes are tracked and the results are again fed back into the system. So hence, we can see that it forms a continuous improvement life cycle program. So these are the digital tools and technologies that enable us in data-driven approach. First, we have the automated road condition survey vehicles. So these are again integrated with the geographic information systems, and we have all these information in a centralized platform known as CRAMS, that is Karnataka Road Asset Management System. And then we have the analytics dashboards. So these transforms the complex data into clear performance indicators such as the condition index, the safety data, and the maintenance cost. So these helps in making quick decision and prioritize our actions. So here is a list of 4 state-of-art equipments like the RCDCV, the falling wave deflection meter, the ground penetration radars, and bridge inspection vehicle. As we know, accurate and reliable data is the foundation for any asset management system. So in this photograph, we can see a road measurement data acquisition system. So it is a special survey vehicle integrated with hardware and software platform to measure the indicators such as the roughness index, the rut depth, the cracking, and the texture. And here we can see the distance measuring instruments and the laser profilers attached to this vehicle. It has also connected to the GPS systems and the cameras to detect the right of way and other features all along the pavement. So this data is applied in the payment management system and also helps in budgeting. It also used in HTM4 analysis and also in preparing our annual works plan. Next we have this FWD. This is used to determine the strength of the pavement and also the remaining life of the pavement. It is a NDT device and it simulates the real traffic loading and it measures deflection to assess its structural capability. So we can arrive whether a road requires rehabilitation or routine maintenance is enough or a complete reconstruction is needed. So the results can be arrived based on this test. So next we have this bridge inspection vehicle. So it provides a safe access to the bridge structures, especially in the difficult to reach areas. So we can structurally detect the health of the bridges, and also it helps in the maintenance and rehabilitation planning, and also in the data collection and assessment, and helps in safety and compliance reporting. Overall, it supports predictive and sustainable mobility. Here we can see some of the visual images where the underside of the bridge we can see the cracks, the spalling, and the exposure of the rebars. So we can detect the overall condition of the bridge using this bridge inspection vehicle. So next we have the automated traffic count. So instead of manual counting, cameras are being installed in selected reaches of the road. So wherein we can continuously record the traffic movement, and these recordings are then processed to get a clear and accurate information on the traffic volume and also the vehicle classification. So all these data, they are consolidated to a platform called the Centralized Asset Management Platform. This is KRAMS. So it acts as a scientific tool for planning, programming, budgeting, and managing road networks. So it is a decision support system. It is also integrated with the road information system, and it interacts with tools like ArcGIS, HTM4, and Transat. So this CRAMS, it has got 5 different modules. And now I'll ask my colleague, Mr. Mahendra Rajaras, to take over this. He'll be briefing on the different modules of this system.
Please try to finish in couple of minutes, right? Yeah. Thank you. Please go ahead. Please go ahead.
I'll just take 2 minutes just to brief on this thing. I'll continue this thing. This is the model which I have customized for Karnataka actually. It's called KRAMS. which you call road, where ma'am said we collect a lot of data using technology. So we need to feed the data and do the analysis. So we have created a module called KRAMS, where we load all the data. It has got different modules. What we call it as, this is the overall architecture of KRAMS, where there is a central database, where all the data from the surveys goes into the database. From there it goes to the different modules, because road data goes to the PMS, RMMS, the bridge data or CD structures data go to the BMS module, the other ESIS module, CAPS, and the other thing is the CAPS module, where we use for the cross-asset prioritization module actually. The PMS mainly what it predicts is the payment condition, whether it requires maintenance or rehabilitation, and it supports the road network management, whether it requires routine maintenance, periodic maintenance, what is the works, whether it has to be taken for widening, improvement kind of thing actually. Then what we do is we load this data for the HDM analysis actually. Once we get the data, we have a HDM4 analysis where we do the life cycle cost actually to arrive at the various this thing, which addition tree making actually. Then we create homogeneous section based on the traffic data, inventory and condition. Then we have 4 different types of analysis: HDM, project, program, and strategy analysis. And the outputs, as you know, we get the annual or multi-year program analysis, because it's not only 1 year, we do it for multi-year analysis, so we get the optimized work program. This is the overall management of the PMS. Methodologies, we create the homogeneous section, we have the condition rating, we select the treatment logic, then we do the economic analysis, then we load the data with the economic analysis with the HDM, we do analysis, we get the outputs based upon NPV by this thing, what we call the benefit cost ratio. And we optimize the optimal treatment this thing actually. And we have a multi-year rolling program. Maybe we do the analysis for the next 5 years or 10 years. What should be the implement program? This is the output what we get from CRAMS actually. How for each section with this. This is analysis we do it for different budget scenarios actually. In case if we get unconstrained budget, what will be your IRI? IRI is the what we call the riding surface from the this thing. What will be our IRI once we should get unconstrained budget? If we get constrained budget, how the deterioration, how your road is getting deteriorated. That is how we analyze this using this module. The other thing is bridge management system. It's same thing where we collect all the data related to bridges, inventory and condition. And here we prioritize bridges using, we have a analysis where we arrive at the condition called bridge condition index. For each bridge, based upon a condition, we arrive at an index called bridge condition index. Based upon that, we arrive at the treatment proposal for each bridge. That's what we say. If it's 100, we say it's newly constructed, and if it's 0, it's fully deteriorated. That's how the bifurcation has been done. The other thing is we collect the traffic data. You know that it's a key performance indicator for the analysis or for the widening option actually. That is where we use this traffic data for estimated traffic flow. This is how we get the output from the system actually, where we can analyze the entire state can be analyzed. What is the PSU? What is the length of your road network? Where the traffic is higher, those analysis can be done using this software actually. The other thing is we have this other module called the routine maintenance management system, where we
Please finish it off in a couple of minutes.
Yeah.
You're already time.
And the last thing is where we have this cross-asset prioritization, where because each module has got its own prioritization, so we have that another module where we cross-asset that we have where we have these 4 major modules. We give the budget scenario for each, and we prioritize the roads and bridges. And ma'am said as we submit this annual research program for Government of Karnataka. Other than this, I would like to highlight this. This is all the data visual mechanics is geotagged actually. It's in the GS module, where any person, any department person can log into the system, can view the data. It's a real-time data, what we have got this here actually. He can view the data, real-time data, his road condition. He can view with videos, with photos, which are attached to these modules actually. This is about the GS-based asset mappings, which we have done actually. And these are the outcomes which we have done actually. It's a statewide scientific-based asset management. We have got advanced data collection, this thing. It's a reduction in reactive maintenance. We have got this thing, condition-based asset management. We have got improved IRA network, safety protection, and we have improved bridge safety monitoring also. And the future roadmap, we need to add AI-based methodology, IoT-based for this bridge health monitoring and real-time data traffic monitoring. These are the future roadmaps which we have assessed actually. And the last I can say that Karnataka is going from reactive to maintenance property, so that we
Thank you so much. Thank you.
Thank you.
Next is Sri Satyendra Prasad Gupta, Superintending Engineer, E&M, CPWD.
Good afternoon. I'll be presenting the step taken by the CPWD for the digital transformation and step taken so far in the implementation of the building information system BIM and some of the use cases of the artificial intelligence. Central Public Works Department, which is 171-year-old department. My previous speaker told about this. So in order to keep the pace with the development around it, so we have to keep unchanging. Otherwise, time will come. The department will perish. So to keep the pace with this, CPWD has started an integrated digital platform, which is known as the e-Nirmit in 2019, wherein its 200 plus processes and 3,000 odd process functionalities are being digitalized through the ERP system. This solution is a modular solution wherein all its processes like administration, project management, HRM, quality management, contracts, etc., will be integrated and will talk to each other, so that whatever we do, and in one aspect of the CPWD do, another aspects get updated and decisions are taken on real-time basis. So this is, and what we had thought is SCADA that we use to monitor the substations. The future is IoT technology, the building information modeling, BMS, imaging, AR, VR, etc. It will be part of this our foundational this ERP. And once we will get the data in the structured format, with the utilization of the data, some data analysis will take place and artificial intelligence will be implemented in some of our process. So this is some of the use cases for the use of the AI, ML and analytics. In this is the automatic updation of our DSR and PR, which is being used not only by the CPWD but all across the public works, all across the country. All the public works department, either they follow or they take the reference from them. This predictive intelligence in legal and arbitration cases, there are predictive analysis for quality and time, cost of construction, condition of the contract documents. All these were thought of. Effective utilization of the human resource, automatic job scheduling. So you'll see once the data in the structured formats are available in ERP system, with the use of the data, some data analytics will be done with some machine learning. These are the points which are supposed to be catered through the use of this artificial intelligence. The key changes that we were expecting from the CPWD with the use of this ERP implementation, it's a process automation, means end-to-end automation, where if you are working in the CPWD, it is either you will have to work on the ERP or you will not be able to work. There is online workflow-based implementation, RFI-based work processes, collaborative integration, because there are a number of the stakeholders involved in the CPWD working. Employees there, contractors are there, clients there, allottees, consultants, arbitrators. So this platform is intended to bring everybody on the common platform and use the data available to perform their task. Dashboard monitoring for each stakeholder, and automation, with automation of the DSR, DAR, cost indices. That is our core job that we do. System enabled preparation for the preliminary estimate, detailed estimate, bid documents, online documents. So these are the key changes that we are expecting from the implementation of this ERP system. More than 60% implementation has already been done and it is being used. So system driven, some transparency and accountability we were ensuring. Real-time data updation means it generally happens to get the report from departments all across the country take times. So we had to deal with the data which are someday old. Now with the this ERP, and we will be able to take the decision on the real-time data. Lots of the monitoring compliances are to be are being done. So with this ERP, it is going to be made easy. There are close to 200 divisions across the country, and so knowledge of one of the units and remains within that unit unless the person gets transferred and spare those knowledge to some other people. Whereas with the use of the ERP system, the knowledge of one person can be disseminated easily to one person, and it can be used for some beneficial this. So around 50% that I have told earlier is 60% implementation has already been done, and it is being used. Within short a while, we will be able to complete the implementation, and entire CPWD will work on this ERP system for all its activity. Now come to the building information modeling. Most of you people are aware about this. What is the building information modeling? This is the digital representation of asset throughout its life cycle, planning, design, construction of the operation. What I'll tell, where we are. My previous speaker told about this is nothing but a process, people, technology, and policy. So this is the standard, just like. The BIM maturity level it is from level 0 with 2D drawings were there only, there was no collaboration. In 2010 itself, we had issued the guideline to start the 3D modeling activity. This comes under level 2, level 1. Subsequently, collaboration using this IFC and construction operation building automation exchange. This comes under level 2. Then level 3 is the cloud-based collaboration, integration with the other information and communication technology. The next level is, again within that level 3, there are another part that is digital twin, which integrates building information model with the IoTs, facilitates the real-time asset monitoring. So CPWD has adopted up to level 3 maturity for the project costing more than 30 crore. In 2023 itself, we had issued the guideline that all the project which is costing more than 30 crore will necessarily be using the BIM, and subsequently the BIM guidelines are also issued. Now there are multiple dimensions. BIM, as you people, everybody is aware, there's 1D, 2D, 3D, 4D, 5D, 6D. So we have mandated up to the 3D, and standalone softwares are being used for the time-related information and cost estimation also. So up to the 5D, we have mandated to use it in our BIM. This is the level of detailing that happens in the BIM. That's a LOD 100 to LOD, which popularly known as LOD. LOD 100, LOD 200, LOD 300. So CPWD has mandated in all their tender costing more than 30 crore rupees to go for the LOD 500. And in some of the projects, we have reached up to the LOD 400. So to spread the use of the BIM, we had held numerous sessions, online awareness sessions for all the stakeholders, whether it is architects, engineers, and contractors, everybody with all lot many awareness sessions has been held. CPWD Training Institute had held lots of the training also. OM release, the contract and CPWD work manual. We have mandated the use of this BIM. This is the artifacts. In 2024, some BIM adoption action plan were issued. Just I'll talk about little. CPWD has started the e-measurement in the ERP system, through which the measurement will be through online, verification will be through online, and the bill will be generated through online only. So data is going to remain on the ERP system. And our billing system are proposed to be integrated with the BIM. And it is still work is going on. E-tendering system and common data environment we have adopted, and e-tendering system is little bit integrated with our in-admit platform. Some of the key area wherein this artificial intelligence can be used, for example, architectural planning. If while having the discussion with leading manufacturer of operators like Autodesk and Tekla, they were suggesting yes, with the use of, they are working on it to prepare the architectural model based on the basis of the requirement, on the basis of its location, basis of the plot. So multiple models can be generated automatically, and it will help the architect to further tune on. The structural design, so is the case with the structural design. If you finalize with a particular architectural plan, the AI-driven structural design can be given, and it will drastically reduce the time for the structural engineers for further analysis and design. So is the case with the AI-driven basis of the past experience and the enormous amount of the data available and the experience we have. The construction scheduling can also be generated with some AI-driven this material selection. For example, the air conditioning system to be used in a particular building, which type of the air conditioning system to be used, whether it is to be ducted centralized ducted systems or BRB system to be used, unity system to be used. So with the use of this artificial intelligence, we can have the multiple options available with us within no time, with cost benefit analysis, etc., etc. The predictive maintenance we can do with the digital twin model that are very much prevalent in the aviation sector. So with the use of the digital twin, if you start constructing the building with the BIM model and updating all the information of all its components, so we can predict the maintenance, which of the component of the building is going to malfunction or are not going to perform the way it should perform. So we can take the we can start the maintenance and early on, and so that the services will be continued over a period of the time. At the same time, if there is there any stress which has been developed in the building, and so if we can get the information on that time, we'll take the corrective measure to avoid any sort of untoward accident. Dispute resolution is one of the issues during the construction and our contracting. So with the use of the artificial intelligence, and a dispute resolution can be done at whether lots of the tools are still available. So this is all about. Thank you very much.
Thank you, SP Gupta ji. Now we are almost on time. It's almost 5 and we have finished. So just to summarize it, Ms. Vatsala, she beautifully demonstrated the use of GIS and their inspection vehicle, their measurement and analytics, their cramps, automated traffic counts, etc. Integrated with GIS. Then SP Gupta ji, he elaborated on the BIM aspect and AI. Mr. Patho Rajan Bakshi ji about the status of BIM in India, the action taken by various departments. Mr. Partha Gandhi, Technical Director, he on timers, various conditions, challenges, and solutions. Ajay Boshi, he also beautifully demonstrated the digital transport beyond construction. So with this, we conclude this. So any questions from audience will be answered by panelists. Over to audience if any question is there. Otherwise, we'll just perform the closing formality.
Yeah, I'll put a question, sir. Are we, what is our capacity building system in place? Because all these technologies are coming in. How are you going to train the cadre that is, on the ground?
Very relevant question. In fact, since 2020, I mean almost last 5.5 years, when I was in headquarters for almost last 5 years, I got trained around 600 architects and engineers hands-on training. Still around 3,000 need to be trained. So training and capacity is big challenge. And apart from this, making available the technologies, the tools, softwares, because softwares are very costly. So going to softwares which are supporting Open BIM may also help it out. So India BIM Association is also working hard to devise some way so that the tools are made available to the people. So that should be the strategy for the organizations to make tools available and train the people so that they can make use of it, because one training or two training will not be sufficient unless it is hands-on training. Very relevant question. I think we all need to ponder over it. In our policy also, we mentioned that we need a continuous training plus availability of tools with the people. Yeah.
So most of the time what happens is that we use proprietary softwares, right, which is not in-house built. So what happens is that every time the proprietary softwares cost
renewals,
pattern changes.
Yes.
The the system gets stuck. Right?
Exactly.
You don't have a transformation that is happening. So
Yeah.
is there a mechanism to develop softwares internally? Right, you have
No.
within,
See, it's a domain of different entities.
Yes, that
we
is
are
there,
the
but-
users. We should work in our domain only, but we should ensure that the softwares which are available are of open BIM kind of softwares which are affordable. Maybe many companies in India are making these softwares apart from Revit, Tekla, right, Bentley. Other people are into it, but their reliability is a little bit doubt. But India BIM Association, they are trying hard to get such people on board and make a consortium kind of thing where these things are made available along with the training and capacity building. So soon we'll be issuing guideline from India BIM Association to all the organizations that please go for these kind of softwares for training and capacity building and further utilization in an organization.
okay, right, sir. But I was thinking the other way, because just like Kerala, we develop most of the e-governance software in-house.
Yeah.
So such kind
Very
of,
right, but such initiative took 4 to 5 years in development of your internal softwares. You did it. I have heard one of the presentations.
because that brings in self-reliance.
Yes.
Otherwise, we'll be continuously depending upon some other. Every time the cost changes, we'll move on to some
Initially, we were thinking to engage NIC for doing this. They wanted 4 to 5 years time for ERP initiative, because it is an integrated ERP.
Right.
I mean, you have 180 modules, sub-processes to, using all standard plus bespoke applications, doing the modification, testing, and for a work life cycle scenario, it's a huge task.
Right.
Yeah.
Right, so thank you. One more question to you. Right.
I have small question to sir. Hello. Yeah. So sir, we are also one portion with software, and we have young team, all are below 25 and very excellent, and now AI comes in software developments. So as per my experience, 10 लोगों का काम अभी एक बंदा कर सकता है very effectively, and the test tool are very effective. But the problem is I am too much interested in this software, but this requires lot of ground experience. I can't assume everything in my office. So is there any opportunity or option we can understand your problems regularly? It's not like when I comes once and I see everything and I put it, because it's day-to-day improvements required, right? So is there government or CPWD, is there any planning we can discuss with them regularly about your challenges, problem or existing software?
See, we have broadly 2 levels of operations. One is our in-house team of architects right? They are using BIM and developing 3D models, BIM models, right?
Okay.
Second is our consultants. They are doing it as a part of vendor-driven initiative. I mean, it's a part of contract.
Okay.
So they are engaging consultants for doing BIM initiative, putting people at site
Okay.
for all monitoring, revision, supervision.
Okay.
So this is the process we are doing.
Okay.
So you may fit into the second one.
Okay.
You can be part of a vendor-driven initiative to supply BIM model, updating it during execution,
Okay.
and further improvements.
Okay. Thank you. Thank you.
Yeah.
Just
Yes,
one
sir.
question with regard to that street lighting thing, right? We have been seeing lots of videos and information from outside India that the color of light that is being used, street light is being changed in many locations, right? For example, it is going to red or maybe some other color. So why that is required, or are we experimenting on such kind of things in India as well?
Sir, basically, you are telling about red, green, and different colors. That is for indication purpose, basically. I think in Rashtrapati Bhavan, there is many poles that indicates at 10 o'clock or 11 o'clock, every visitor should go outside. It's a time close now. So that purpose, in many countries, they are using for emergency vehicle indication. In India, that still that acceptance and not has been there. लेकिन I think कुछ चीज़ों में अभी वो improvements हो रहे हैं, POC level पे काफ़ी जगह पे हो रहा है. But in India, I think it will very helpful to us because things are very unorganized. So I think this kind of technology can be very helpful, and we already developed this kind of indications in individual controller. So if ambulance is coming to from one road to second road, that pole will indicate the direction, because at zebra crossing it's very difficult for everyone ambulance को कहाँ पे जाना है. So that we can definitely use, sir.
So my one question is to organizer.
बताइए sir.
See all wonderful presentations going on.
Right, sir.
I think we should publish a book. At
So
least
I
one
think-
page giving to each person who have spoken with their unique ideas.
Yeah, earlier we used to do that. Now it's all electronic world.
I
now,
think
so it
you
will be
may
available.
ask for a single pager from all the presenters, which
it-
they want to get duplicated.
We'll put
adopted.
it on our website, sir. We'll see to that. It is there on our Municipalika website, and it is available to all of you.
Oh,
Right? So
great.
that we'll do. Because printing, publishing is
Yeah,
become
I
mostly
understand.
outdated.
It should be in booklet form, maybe in that website itself.
We'll do
As a
it in the
PDF.
website, right? In the form of
Yeah.
e-book. We'll
Yeah,
try to do
wonderful.
it.
Yeah, wonderful.
Right. Thank you, sir. Thank you very much. So, any more questions from audience? So, let me proceed with the presentations. Let me ask Devendra sir to present mementos to all the fellow panelists.